Hi everyone. So the next topic which I learned was discrete random variables, and I'll try to explain that. So let's begin. So far, events are arbitrary sets, and random variables assigns a number to each outcome. Okay, so this lets you do arithmetic on uncertainty, like add, average, and take expectation. So, discrete random variables can only take countable many values. It can be finite or countably infinite. And how it is represented as like sample space colon x implies r. Okay, like here it is shown. Now there are two things in it. PMF means probability mass function. It says how probable is each specific value. Okay, and the second thing is TDF, which shows how probable is a value less than or equal to x, as you can see here. Okay, now moving to next. What is probability mass function? So, you can see this formula. So, in this valid PMF condition, which probability mass function have to satisfy, it's first non-negativity. Second is that sum equal should be 1. And third is that bounded range should be equal to 0 for any x not in range of x. Okay. Next is like CDF, cumulative distribution function. Now in this, this is the formula, it's how we represent it. And like properties, every cumulative distribution function must satisfy the non-decreasing, right, continuous, and limits. Non-decreasing means like if x1 is less than x2, it implies that a function of x1 is less than equal to function of x2. And it is like probability only accumulate, it means. And second thing is right continuous, means that Hmm. Right hand limit means of f of x plus h is equal to f of x. Means jumps happen at the point, not after it. Okay. Then there is limit. Limit means the both sides, like nothing below and everything above. Like limit x tends to negative is that is equal to 0, which means nothing is below, and the limit extend to infinity positive is equals to 1, means everything is above. Now, if we see the transformation cycle of these, so how we recover PMF from CDF? It's like just here's the formula you can see here. The how this is how we do it, where f of x x minus is equals to the left hand limit, and the jump size at x is equals to the probability mass at the x. Now moving forward, this is a question first of all. So in this, like roll a fair die and let x is equals to the outcome. So the range will be after rolling a die will be from 1 to 6. The PMF will be 1 by 6 for each element of x, like 1 to 6. Otherwise it's 0, right? Now what is the total probability? How we will check? Just sum all the events which occurred into the probability of each event, which is 1 by 6. So we got the answer as 1. Now how we will do CDF? Means x is less than equals to 1. Okay, here only it is x is less than equals to me 1, then function will come up as 0. If it is greater than 1 and less than 2, then it's 1 by 6. And if it's greater than 2 and less than 3, it's 2 by 6. And moving on forward like that only. And at the end, when x is greater than equal to 6, it means the function will re- mm, give outcome as 1. So, moving forward, just see another example in which, like it's non-uniform PMF. The previous example which we saw was a uniform PMF. In non-uniform PMF, let's take a thing like x is equal to number of heads and two fair coin flips. And the range will be like 0 heads will come, 1 head will come, and 2 head will come. More than that, nothing can occur. So the outcomes you will write like when 2 will come, x is equals to 0 because x is the count of heads. Then when head and tail and or tail or head comes, the x is equals to 1. And when both heads will come, x will be equals to 2. Now just put the value and you will see that the probability of x equals to 0 is 1 by 4. Probability of x equals to 1 is 1 by 2. And probability of x equals to 2 is 1 by 4. Now, how you will write the function like CDF function? So, x less than 0 is 0. And from 0 to 1, it's 1 by 4. And from 1 to 2, it's 3 by 4. Means like all the things below will take. So 1 by 2 plus 1 by 4 is like 3 by 4. Right? Then like above 2 will be equals to 1. Okay. Now moving forward, just the translation matrix. Okay. This is just how we translate it, the simple thing. Okay. So if probability of x less than equals to a, it means formula translation will be f of a. If it is like how we did in back to questions, now same all these formulas are just written here. So moving forward, these are the pitfalls where you can make mistakes in this topic. So RV is a function first of all. It's not a variable. So X is a deterministic function. Okay, the randomness in the omega, not in X itself. Okay, randomness will be seen in the omega means the outcome. So X is random. Uh, and in shorthand for the input, the omega is random. This matters when you compose function in random variables. Okay. And there is one more confusion we face like probability of x equals to x and probability of x less than equals to x. So these are completely different quantities. X equals to 3, 1 is equals to 1 by 6 for a die. And x less than equal to 3 will be 3 by 6 for a die. Okay. Then there is PDF is right continuous, not left continuous. Remember it. Then PMF is a non-integer value. So for the die, if probability is at x equals to 2.5 is equals to 0, it's not defined, okay? Just 0. The PMF is defined on all of the real values. So it just happens to be 0 everywhere except the support value. Now, there is one more mistake like confusing PMF with the probability directly. The PMF gives the probabilities of the discrete random variable. And for continuous random variable, which will be our next topic, there is a function which is PDF, probability density function. It does not give probabilities at any point, okay? It gives probability density. So treating PDF like a PMF is one of the most common conceptual errors in the entire topic, okay? Next thing is like support versus range. The support of a distribution is the set where probability x is greater than 0. Okay, the range of x as a function from sample space is the same thing here. So in some textbooks, we use these interchangeably, others don't. Okay, so know which one your source means. Now, why we are studying this? What is the American connection? So, first of all, classification output. In this, like softmax produces a PMF over classes and which is non-negative and sums to 1. And second thing we use in language models like probability of next token given context is a PMF over vocabulary. Okay. Now there is one more use case. It is like multinomial distribution, which is our forward topic. And in this, we just generalize this to multiple classes settings. Okay. And fourth where we use is like cross entropy loss. Okay, this is defined in terms of PMF of the two distributive versus predicted fundamental to, and it is very much fundamental to training classifiers. Okay, so this was all about this topic. In the next video, I'll talk about PDF functions. So till then, bye bye.